Okay, so once again, guys, just in case any one of us came in a little bit later, okay, just in case some of us came in a little bit later here, our chapter 4 review, we go to our chapter 4 page. Okay, we're going to scroll down to chapter 4 test review. Our test is this Wednesday. Once again, our test is this Wednesday, December 16th. So you're going to click on the chapter 4 review / practice. Okay, and it's going to bring us over here. You are going to complete the problems that have been, wait, some of the highlights are not there. No. Okay, you are completing specifically numbers 3, 4, 5, 6, 8, 7, 8, 10, 11, 12, and 13, and number 18 and 19. Okay, these are the problems that you are going to complete. Now, after you complete these, you are going to then go to your big ideas. And on big ideas, you have a chapter review assignment. You are going to input your answers, okay, into the review assignment. It's the same questions as on the PDF. And that's going to be how you're going to turn in your practice assignment. So right over here, okay, this will unlock at 3 p.m. You're going to start it and you're going to input these answers. So I don't need you to scan. I don't need you to upload. You are literally going to input your answers and get the feedback right away. Okay? Any questions? Okay, so let's see here. Can I get a thumbs up in the participants window if you have your PDF open and you have paper out that you can work on? Okay, thumbs up if you have your PDF open and you have paper out that you can work on.
I've copied it down. Can I just use that instead?
The questions, you mean?
Yeah.
That's fine. Okay, still waiting for some people to give me a thumbs up that to show me that they are ready to get started. Waiting for Callie, waiting for Zavon, waiting for Josh and Joe and Harmony, as well as Bethany Ann. I want to say thank you to Andres Leon, Andres Moreno, Caleb, Destiny, Gabriel, Heaven, thank you. Jasmine, thank you. Jayla and Jose, thank you. Joshua, thank you. Kebra, thank you. Leanne, thank you. Mariel, thank you. Michael, thank you. Maya, thank you. Samson, thank you. Zavon, okay, for being ready and ready to get started in class.
Wait, what were you waiting for us to do?
I'm waiting for you to give me a thumbs up to show that you have the PDF open and paper out to work on.
All right, there, I did it.
All right, thank you. All right, so let's go ahead and get started here. Okay, I'm gonna go ahead and pin my video so that it's recording nice and large here. Okay, so our first question, ladies and gents, our first question that we're working on, okay, is going to be number 3. Now, number 3 has directions. It says graph triangle, okay, XYZ with vertices X at 2, 3, Y at -3 and 2. Okay, so I'm going to write down my directions here. Y at -3 and 2, and Z at -4 and -3. Okay, they want us to graph it. And the translation that we're working on is x comma y goes to x plus 3 comma y minus 1. Okay, so this is our first problem here. Okay, so we want to graph this and the translation. Okay, so I'm going to start by drawing a nice XY table here, or a graph. Okay, and yeah, sometimes you just got to make your own graph, right? Okay, so the first thing we want to do is we want to actually graph our pre-image, XYZ. Okay, so we can make some markings here to help us graph. We're not perfect, that's okay. Okay, so our pre-image is XYZ. So my X is at 2 comma 3. So 2 to the right, 3 up. I hope I'm giving myself enough space. Hold up. Yes, okay. So 2 comma 3. So 1, 2, 3. This is my X. Okay, my Y is at negative 3 comma 2. 1, 2, 3, and then comma 2 up, 1, 2. This is my Y. My Z is at negative 4 comma negative 3. So negative 4 and negative 3. Here is my Z. I'm going to draw and connect my dots, my lines here. Okay, there we go. There's my pre-image, XYZ. Okay. Now there's a couple of ways you can translate, right? You can do it based on the coordinates, or you can just count. Okay, it's completely up to you. There's no right or wrong here as to which method you choose to use. Okay. If you choose to count, you're going to have to make sure you recognize exactly what this +3 for the X means and this -1 for the Y means. Okay. So if I have an X +3, remember X moves in right or left. So if it's a +3, that means we're going to be moving 3 to the right because we're adding 3. Okay, Y is an up and down motion, right? Which means that if I have a Y -1 for a Y means I'm going to be going 1 down. So if you count using the graphs, okay, every single one of these points, you are going to count 3 to the right and 1 down. So if I take X 3 to the right, that's going to be 1, 2, 3 to the right, 1 down. My new X prime will be right there. Okay. I can do the same thing with Y. 3 to the right, 1 down. 1, 2, 3, 1 down. Here's Y prime. Same thing with my Z. 3 to the right, 1, 2, 3, 1 down, right over here. This is going to be my Z prime. There we go. That's our translated triangle. And if you choose to do this algebraically using our rule, then that means we are going to take each one of our coordinates here, and we're going to add 3 to the X and subtract 1 from the Y. So my Z here is -4, -3. Okay, so that means every single one of these points, I'm going to take each one of these. So 2 and 3, -3 and 2, -4 and -3. So I'm taking each of these X and Y's And I'm going to be adding 3 and subtracting 1. So adding 3 to the x. So let me grab a different color here. Okay, so plus 3, plus 3, plus 3. So every single one of these x's, we add 3 to. Okay, and then every single one of the y's, I'm going to subtract 1 by. Okay, subtract by 1 there. So then what does that give me? That gives me my x prime. 2 plus 5, or 2 plus 3 is 5. 3 minus 1 is 2. So my x prime should be at 5, comma 2. And if I take a look at this guy, okay, this x prime here, I have 1, 2, 3, 4, 5, 1, 2. I'm a little bit off there, but that's okay. That happens when you make your own graph. Okay, so x prime. Y prime, same thing. Negative 3 plus 3, that's 0. 2 minus 1 is 1. So y prime should be at 0, comma 1. Here's y prime, that's at 0, comma 1. 0 for the x, up 1 for the y. My z prime here, negative 4 plus 3. Negative 4 plus 3 is negative 1. Negative 3 minus 1, okay, that's the same sign, so keep the sign but add. That's going to be negative 4 here. My z prime should be at negative 1, negative 4. Let's take a look. Here's z prime. I have at negative 1 for the x. And then for the y, I have 1, 2, 3, 4. So negative 4. So negative 1, negative 4. Okay. So no matter if you do it this way or you count, as long as you do the math correctly and count correctly, obviously, you should end up in the same positions. Okay. So over here, I would suggest that you leave some space so that you can do your number 4 on your own. Okay, so number 4 is, this is the one you're gonna do, okay? And I'm gonna continue with number 5. Please leave more space than that for yourself. Obviously, I don't wanna waste paper, but leave more space for yourself to work on number 4. I'm gonna move on to number 5 now, okay? Now number 5, let's see. Number 5 says graph triangle PQR, okay, with vertices. They give us our vertices there. I'm trying to find the zoom in. There we go. Zoom it. That's what I wanted. Okay, here we go. Okay, so we have PQR at P at 0, negative 4. Okay, 0, negative 4. Q at 1, comma 3. And R at 2, comma negative 5. Okay. And we have 2 translations. So we have translation 1 is going to be xy goes to x plus 1, y plus 2. And translation 2, so we have a composition of translations here. Okay, xy will go to x minus 4, comma y plus 1. Okay. So here's our number 5. Okay. The directions are to graph the triangle and its image after the composition. Okay. So again, we're going to start by drawing our graph here. Now, if you're using graph paper, this is like 10 times easier for you, right? Because it's graph paper. But I'm going under the assumption that many of you don't have graph paper, which is why I chose to use regular paper so that we're all on the same page here for the most part. Okay. And I'm just making my markings like as evenly spaced as I can, honestly. that's the whole goal here. You just want to keep things as evenly spaced as you possibly can. Okay. This is 1, 1, -1, -1, right? Going by ones here. All right, so let's start by graphing our original PQR here. P is at 0, -4. So 0 for the X. Okay, don't move right or left. 0 for the X and -4. So 1, 2, 3, 4. So here is -4, just from how I labeled things. Okay, so this is P. There we go. Okay. And then Q is at 1, 3. So 1 and 3. So 1, 2, and 3. There we go. That's our Q. R is at 2 and -5. So here is 2, 1, 2, and -5. So 1, 2, 3, 4, 5. Okay, there is R. So I'm just going to connect here. Okay, there we go. There's our original. Okay. Now, if you're going to count, okay, you're going to have to make sure that you do the translation number 1 first, and then do translation number 2 from translation number 1. Okay. If you're going to do it algebraically, it's the same idea. You have to do it with translation number 1 first and then translation number 2. So you have to remember that it's a relay. Okay, it's a relay. So this passes the baton on to this one, and then this one passes the baton on to that one. Okay. So if we do translation number 1 first, now I know all of you can count. So I'm going to do this algebraically so you guys can see another example of the algebraic done, okay? Because I have full faith that all of you can count here. So for the translation number 1, okay? Translation number 1 here. Our starting points are P, Q, and R. So our P, here's P0, -4. Q is at 1 and 3. R is at 2 and -5. Okay. Now the translation is x plus 1 comma y plus 2. That's our translation here. So once again, I'm going to take every single one of my x's and my y's. My x's, okay, I'm going to add 1, 2. So I have 0, 1, 2. Okay, I'm going to add 1 to all of them because the x is being added by 1. Okay. And then my y's, -4, 3, and -5, right? I'm taking them from the points. I'm going to add 2 to each of them for the y's. Okay. So that results in P prime. And P prime will be at 0 plus 1 is 1. -4 plus 2 is -2. Q prime, 1 plus 1 is 2. 3 plus 2 is 5. Okay. And then R prime, 2 plus 1 is 3. -5 plus 2 is -3. Okay. That's translation 1. The directions, however, they want the original triangle and its image after the translations. So we don't need to graph this middleman. Okay, this is only the middleman. This is the relay. The finish line is after translation 2. So now we're going to take our P prime, Q prime, and R prime, and we're going to do translation 2 to it. So our starting points here are going to be these guys. So I have my P prime at 1 and -2. I have my Q prime at 2 and 5. And I have my R prime at 3 and negative 3. Okay. Now the rule that we're working with here for translation 2 is we have now x minus 4, comma y plus 1. That's the rule that we're working with. So that means that each one of these points now, I'm going to take my x's, 1, oops. Okay. 1, 2, and 3. Wow, that was weird. Okay, so 1, 2, and 3. And I'm going to subtract 4 from them. So minus 4, minus 4, minus 4. Because that's what the rule says to do with x. Okay. Then I'm going to take my y's, negative 2, 5, and negative 3. And now I'm going to add 1 to each of them. Add 1, add 1, add 1. Okay, so this is now going to get me my p double prime, my q double prime, and my r double prime. So my p double prime, 1 minus 4, negative 3, negative 2 plus 1, negative 1. Q double prime, 2 minus 4, negative 2, 5 plus 1, 6. R double prime, 3 minus 4, negative 1, negative 3 plus 1, negative 2. Okay, this is now our finish line. So now we're going to graph our final image here. So P double prime is at negative 3, negative 1. So I'm going to go negative 3, 1, 2, 3, negative 1. This is P double prime. Okay. Q double prime is at negative 2, negative 6. So negative 2, I'm sorry, negative 2, positive 6. I apologize. Negative 2, positive 6. So negative 2 and then positive 6. So we have 1, 2, 3, 4, 5, 6. So now this is my Q double prime. And my R double prime is at negative 1, negative 2. So negative 1, negative 2. Here's my R double prime. Connect my vertices here for my triangle. And there we go. So this guy got moved from here to wherever those points took it, and then those points to our final drop off. Okay. So you will then do number 6, right? So number 6 is on you. Okay. So do me a favor. Go ahead and take, I'm going to give you guys 5 minutes to get number 4 and number 6 started. Okay. I'm going to give you guys 5 minutes to get number 4 and number 6 started on your own. Okay. And then we're going to move on just so that you guys have a chance to think through the process yourselves. All right, ladies and gentlemen. So let's continue. Yes. Moving on to our next question, which is, okay, I don't know why the highlights didn't show, but they are for sure number 7 and 8. I don't know why the highlights didn't come out when I uploaded it to Google Docs or Google Drive, but 7 and 8. So we're going to go on and we're going to do number 7 here. Okay, so I'm going to flip this over on my page. Okay, and I'm going to write down my question. So it says graph the polygon and its image after a reflection in the given line. Okay. So number 7, we have x equals 4 as our given line. And we have a triangle there. I'm gonna draw the triangle here. Okay. So let me mark some of this stuff here. Okay, and just in case over here and down here. Okay, A seems to be at 1, 2. So 1, 2. Here's A. B looks like it's at 3, 4. So 1, 2, 3, and then 1, 2, 3, 4. So there's B. And C seems to be at 5 and 1. So 2, 4, 6, 5, and 1. So here's C. So here's the triangle we're starting out with, okay? So there's our triangle there, okay? And yes, we do need to start out with this. Now, we do have a rule. We do have rules for reflections, but not across basic lines like this. The rules that we have for reflections are across lines like the x-axis or the y-axis, or the y equals x line or the y equals negative x line. But if you remember, I said whenever you have a reflection across like a random line, like a horizontal or a vertical line, the key is to count, okay? So first thing we want to do is we actually want to draw our line. So x equals 4. So I'm going to go to 4 on the x-axis. So 1, 2, 3, 4. Here's x equals 4. If I draw a line like this, that's actually the x-axis. So I want to draw a line that's going through x equals 4. And that's going to end up being a vertical line here. Okay. So this is my x equals 4 line. This is what I'm reflecting across. And you might be like, but Miss K, it's going through the triangle. How are we going to reflect? Don't worry. We're just going to take that and flip it over. Okay. So easy peasy stuff. We're going to count. Sorry, I didn't mean to move my paper. We're going to count. So we're going to start with A. The whole goal, since we're reflecting across a vertical line, whatever's on this side is going to mirror on the other side. And whatever's on this side is going to mirror on the other side, right? So if it's on the left, it's going to mirror to the right. If it's on the right, it's going to mirror to the left. So the whole idea is to count the distance to the mirror and then reflect that distance on the other side. So we'll start with B because B looks like it's really easy to do. B is at 3 on the X. So it's only a distance of 1 to get to my line, which means I'm just going to go a distance of 1 in this direction. And this is going to be my B prime. Okay, easy peasy. For A, okay, A is at 1 here. So I would have to go 1, 2, 3. A distance of 3 to get to my line of reflection or my mirror. So I'm going to count 3 in this direction now. So 1, 2, 3. So this is going to be my A prime. Notice the level did not change, right? The Y level did not change. It's just a pure reflection, okay? So I brought over my A and my B. I can connect these guys. Now C is on this side, so I need to reflect C prime over. So now I just go this way. So I have to go 1 this way. That means I'm going to go 1 the opposite direction. And this is going to be my C prime. So if I go ahead and connect my vertices here, we can see our reflected triangle. And if I get rid of these lines that I drew for the distance for B, it's going to look even better. Okay. Bam. There is my reflected triangle across the line, x equals 4. Okay. So you guys are now going to do, not now, but you are responsible for number 8. Okay, you will be responsible for number 8 there. Okay. So next question after number 8 is number 10. It says, graph the polygon with the given vertices and its image after a rotation given the number of degrees about the origin. Okay. So for number 10, I'm gonna do it right under here. So number 10, the vertices we're given is A is at -3, -1. B is at 2, 2. And let's see. C is at 3, -3. And we are rotating it 90 degrees about the origin. Okay, so this is what I have for number 10 so far. I'm gonna do this so you guys are clear. So if you remember from class, if all they gave me was 90 degrees, and they're talking about 90 degrees counterclockwise, okay? So we're rotating 90 degrees counterclockwise. So first things first, I want to graph. I'm going to make my graph a little bit smaller this time, just to save space. Okay, so I have my A at -3 and -1. So let me mark my my points here. It's important to mark your points, honestly, because it helps you graph. If you don't, then it just visually, I mean, it's not perfect even when you mark it, but visually it just helps you, you know? So this is 2, this is 4, this is 6, -2, -4, -6, 2, 4, 6, and then this is going to help us just keep track of our spacing here. Okay, so A is at -3, -1, so 1, 2, 3 to the left, and then down 1. That's A. B is at 2, 2, so 1, 2, and then 1, 2. Here's B. C is at 3, -3, so 1, 2, 3, and then 1, 2, 3, right here. So here's my triangle. And I want to rotate this 90 degrees. Now, counterclockwise means we're going this way, right? Because that's opposite an actual clock. Clock usually goes this way, right? Counterclockwise this way. How did I know it was counterclockwise once again? When they don't give you an actual measurement, okay, then it is counterclockwise. That is the default. Okay. All right. Now, here's the thing, okay? We can use parchment paper if we wanted to. We can. We can use parchment paper and we can rotate this like no other business, okay? Or we can use our rule, okay? Rules are more algebraic and they can allow us to find the points and then graph the points, okay? So for a 90-degree counterclockwise rotation, okay, a 90-degree counterclockwise rotation here, our rule is that x, y, okay, goes to, now every time we rotate 90 degrees, every time we rotate a 90 degrees, our variables are gonna flop, they're gonna switch. So it's gonna go x, or it's gonna, the x and y are gonna switch, okay? Now, with that being said, there's also a change, okay, in one of your variables and its sign. So when we rotate, okay, when we rotate this way, counterclockwise, 90 degrees, okay, our variable, one of the variables here, this one is going to change signs, okay? So this y that becomes your new x will change its sign. So if I have my a, -3, -1, my b, excuse me, 2, 2, and my c at 3, -3, okay? These are my starting points. Now, to get a prime, b prime, and c prime, I follow this rule, okay? I follow the rule that my x and y are going to switch. So every point that you see here, the x and the y are going to switch. So all of my x's are now going to be the y's of my new points. And they don't change sign. It is what it is. X becomes x. Okay, so exactly as they are, I'm going to bring them over. So this is -3, this is 2, and this is a +3. Okay, I brought my x's became the y's here. Okay, now the y's here are going to become the x's here, and they're going to change sign. So -1 comes here, but it changes sign, so now it's a +1. Okay, this 2 here, okay, I'm sorry, this 2 here comes over here as the x, and it changes the sign, so it's a +2, which means now it's going to be a -2. Okay, this -3 for the y in the original is now going to be the x here, but it's going to change its sign, so that's now going to be a +3. Okay, and you don't have to do this all at once. You can bring it over and then change the signs. It's really up to you. If you can do it automatically, even better. If not, then there's nothing wrong with that. Then that writing it down and then going through and changing the signs. So if it was -1, making it positive, positive becomes negative, negative becomes positive, right? And then we graph this. So a prime is at 1, -3. So 1, I'm sorry, 1 this way, and then -3. So this is going to be our a prime. B prime is at -2 and 2. So -2 and 2. This is B prime. And C prime is at 3 and 3. 1, 2, 3, 1, 2, 3. Here's C prime. Okay. And if you'll take a notice here, it looks like every single one of these points has literally turned into the quadrant right next to it. So A turned 90 degrees and went here. B turned 90 degrees and went there. C turned 90 degrees and went there. Okay. If you do it with your parchment paper here, just quickly showing you here, the original triangle is right here. If I rotate this 90 degrees counterclockwise, match up the origin again. Okay, and it pretty much falls in around the same position. It's going to look off because I don't have a perfect graph. Like I don't have perfect like spacing and numbers and all that wonderful jazz. Okay. All right. So you are responsible for number 11 and 12, actually. Okay. You are responsible for numbers 11 and 12 because number 12 is just a composition of a reflection and a rotation. So you're good. It's all you. Okay. Number 13 is about rotational symmetry. Okay. So rotational symmetry is just asking you, does our figure, like if I were to rotate it, does the figure land on itself? Okay. And how many times does it land on itself? With what degree? So if we take a look at that star, I can't really draw that star, but if we take a look at that star and we were to take and rotate that star, okay, if I rotate it like 90 degrees or even 45 degrees or 180 degrees, the star will end up landing on itself, right? So if I have a star like, I don't think I'm going to be able to draw a perfect star, guys. Yeah, that's definitely not a perfect star. It's not going to land on itself. But do number 13 as well. So over here we have, what is it, 11, 12, and 13. That's all you. Okay, it's all you. Which brings us down to number 18. We now have dilations. Okay. So number 18 says, graph the triangle and its image after a dilation with a scale factor of K. So we are given P at 2, 2, Q at 4, 4, and R at 8, positive 2. I almost thought it was a negative 2. My bad. Yeah, positive 2. And our scale factor is K equals 1/2. Okay. Real quick, if K equals 1/2, so sorry. If K equals 1/2, is that a enlargement or a reduction?
Deduction.
It is a reduction. Thank you. And can someone else tell me why it's a reduction? Anyone? Why is that a reduction? Reduction is correct, but why? How do I know it's a reduction?
It's less than 1.
It is less than 1. Absolutely. Okay, this is a reduction because K is less than 1 but greater than 0. If it was bigger than 1, it'd be a enlargement. Thank you, Gabriel. I appreciate you, buddy. Okay. So the beauty of a dilation, guys, is that there's really one rule. In order to get the new points of your dilation, it's pretty much the same rule. You multiply each one of your coordinates by your K. So you get the new coordinates by doing K times X and K times Y. Okay. So I can figure out P prime, Q prime, R prime before I even graph anything. Okay. So I can do that here. P is at 2, 2. Q is at 4, 4. R is at 8, 2. And if I want to get P prime, Q prime, and R prime, all I got to do is multiply each one of these guys by my scale factor of 1/2. So this is going to be 1/2 times my X and 1/2 times my Y. 1/2 times my X and 1/2 times my Y. 1/2 times my X and 1/2 times my Y. So I'm just going to plug in the X's and the Y's from each of the points. So to get P prime, it's going to be 1/2 times 2 and 1/2 times 2. Q prime will be 1/2 times 4 and 1/2 times 4. R prime will be 1/2 times 8 and 1/2 times 2. So then I just simplify these puppies. P prime will be 1/2 times 2. Remember, that's the same thing as doing like 2 divided by 2. So I get a 1 and a 1. Q prime, that's 4 divided by 2. So 2 and 2. And R prime, 8 divided by 2 is 4. And 2 divided by 2 is 1. So there are my new points. okay? And to fulfill the question now, which said graph this triangle and its dilated image, okay, I can now just literally make a graph. Ba-bam, 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 ba-bam. Okay, looks like everything's in quadrant 1, really. Dang it, I could have, hold on, I'm gonna make my life easier, yo. Everything's positive, so it looks like everything is in quadrant 1. So I'm gonna give myself some more space here. Instead of making the y-axis in the middle, I'm gonna literally bring it over a little bit and give me some more space to work with. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so 2, 4, 6, 8, 10. And then do some stuff on the y-axis to give us some y's to graph. I got a 2 and a 4 and a 6 and an 8 and a 10. There we go. And then I'm just gonna graph my triangle here. So P is at 2 and 2. Q is at 4 and 4. And R is at 8 and 2. Oh boy, 8 and 2 right there. I'm gonna connect my vertices here. That's the pre-image right there, right? That's the pre-image. I just graphed my pre-image. Now I'm gonna graph my dilated image, which should be a reduced size, right? Specifically, it should be half of the original. So P prime is at 1 and 1. There's my P prime. Q prime is at 2 and 2. Here's my Q prime. And my R prime is at 4 and 1. So 4 and 1 right there. R prime, bam, bam, bam. That's my image. It's triangle PQR and it's mini-me. Okay. So that means number 19. Oh, you. Okay. So once again, let's review. Once you have completed all of the problems, okay? Once you have completed all of the problems, and once again, let me write down the specific numbers you're working on. Okay, you are working on 3, 4, okay, 5, 6, and 7 and 8. Okay. And then after 7 and 8, it's 10, 11, 12, and 13. So 10, 11, 12, and 13. And then 18 and 19. Okay. 18 and 19 here. So we have already done number 3. We have done number 5. Okay. We have done number 7 and 10 and 18. So I've already done 1, 2, 3, 4, 5 of the problems for you. You have left 1, 2, 3, 4, 5, 6, 7 problems left. That's it. Okay. When is your test again?
Wednesday.
Wednesday. Thank you. Wednesday. Do not forget, please. Do not forget. How do you turn this in? Any takers? How do you turn this in?
Big Ideas Math.
On Big Ideas Math, yes. You're literally going to go, you're going to click on the assignment, and you're going to input your answers as you go. But you got to finish the other 7 problems before you start inputting your answers. Yeah? Okay, we have 15 minutes left to class. We are not leaving. I want you guys to get started on the 7 other problems, okay? And if you have any questions, please make sure that you ask them before you head out, okay? And Destiny, you asked, will I be posting this video on Canvas? Absolutely. Once we're done with class, it's going to process. I'm going to upload it to YouTube, and I'll link it to the review row, okay, for chapter 4. All right, ladies and gents, get to work.